Hey everyone, today we're going to do a problem where we're going to try and clone a linked list. But the little twist to this problem is that this is not just a normal linked list with pointers to the next node. This linked list is also going to have pointers to random nodes in the list. So as you can see in this example, each node has 2 pointers. And I sort of had to represent this a little weird because it's in a text editor, but hopefully you can tell. So these nodes each have a pointer to the next node. So this is sort of our normal linked list here. And then we have an additional pointer in each node that points to a random other node in our list. So in this case, this one node points to the 2, and then its random pointer points to this 3 node. And then this node points to the 1 node, this node points to itself, which is fine, and this node points to the 2 node. So what we're going to try and do is we're just going to try and clone this linked list. And first of all, let's make sure that we ask any questions that we have of our interviewer. So the first thing that we want to do is just clarify the problem and make sure that we understand exactly what's being asked. We just talked about this a little bit, but if you don't understand how this linked list is supposed to work, make sure that you ask any clarifying questions about just like the structure of the linked list so that you are answering the right question, because you wouldn't want to get halfway through the problem only to realize that you had done the wrong thing. So that's really important. And a couple other more specific questions. Things like, can the random pointer in a node point to itself? If the example didn't have this in it, that would be an important question to ask, because that could change maybe how we solve the problem. You can ask what the values of the nodes are. Like, are the nodes going to be the integers, or are they going to be strings, or what's going to be in them? Maybe could the random pointer be equal to null? Questions like this that are just good to understand exactly what we're dealing with here. And so what we're trying to do is to actually clone this list. And so let's talk about how we're going to do that. So the thing that I think about first is just cloning a regular linked list is pretty easy to do, right? Because all we have to do is write a loop that's going to loop through our original list and copy each node and make a duplicate of each node, link all those nodes together, and copy the values from the original list into the original node into its duplicate node. So that's fairly easy, and we know how to do that. But what is going to make this more difficult is that we have these random pointers in addition. And we can't so let's imagine that we're copying the linked list. So we copy the 1 node, and now we want to copy this pointer. We want to copy the pointer to 3, but that node doesn't actually exist yet in our duplicated array, or our duplicated list. So we can't create that pointer right now because we don't even have a node to point to. So what we could do is we could say, okay, we have a random pointer to this node, so let's create the node. We'll create a node 3, and that's just going to sit off here, but this node is pointing to this next pointer is pointing to null, and this is pointing to 3, and then we would come add this next 2 node, and this is going to point to 1, which we know because we already created the 1, but now we still don't have, this doesn't point to anything, and now we're going to create a new node 3, and now we've accidentally duplicated this node. So as you can see, it's a little bit tricky. We're going to have to think of a better way to do this. And so let's talk about a couple ways we could do it. The first thing that would make sense to me is that we could actually do 2 passes through this. So let's imagine that we do what we were doing before, but we're going to start here. We're going to we're going to create our first node, and we're going to initialize the random pointer to be null. And we're going to do this for all the nodes. We're going to basically we're going to iterate through our original list and create a node for each node in the original list. So we'll do 2, we'll do 3, and we'll do 4, and it points to null. And then all of these are going to point to null. So I'm not going to write it, but they are pointing to nothing. There's no node. So, and then what we can do is we can do a second pass over this, and we want to map them. We want to match them up. So this is going to be a little tricky with exactly what we have here. So we would basically iterate through this original list again. So this is so it's a little hard to notate because I'm notating it by node value, and the values are obviously the same, but these are actually 2 discrete, these are different objects with the same values. So we would iterate through our original list, and we'd see that this points to 3, which is fine. So we know that it points to this node in our original list. But that still doesn't help us exactly because we don't know what node it should point to in our actual list, in our new list, right? So we need to figure out what node this should be pointing to in our new list. So what we can do is we could actually create a mapping of our nodes in our new list, in our old list, to our nodes in our new list. So let's say we had this mapping, we would basically have 1 to 1, 2 to 2, and these are old list to new list. So node in old list mapped to node in new list. So 3 to 3 and 4 to 4. And this is our mapping. So now we go here. So what we would do is we would iterate through this. We would find that the random pointer points to this 3. Then we go to 3 in this list and look it up in our mapping. And now we have the 3 in the original list, and then we have its equivalent node in our new list. And so what we can do is we can get this from the result of getting from this list is the 3, and then we know to put the 3 there like that. And so we can do this for all the nodes and basically do 2 passes through and use this mapping to map nodes in the old list to nodes in the new list. And that way we can assign all the random pointers the way they should be. So that's one thing that we can do, and that's a pretty good solution. This is going to run in linear time. We're doing multiple passes of the list, but it's still, each pass takes linear time. And then we're using linear space, right? Because we're taking this, we're making this map, which is going to take up linear space because it's going to take up a constant amount of space for each node in our list. So that's a pretty decent solution, but we can actually do better than this space-wise. So let's think about this for a second. So space-wise, we're always going to take up linear space no matter what our algorithm is because we're generating a new linear length list, right? We're going to generate this whole thing. So by definition, our algorithm is going to take linear space. So when we think about the space of this, what we really want to do is think about the space in addition to that list that we're generating. So this is taking linear space in addition, but we can actually come up with an algorithm that's going to take constant space in addition. So for this algorithm here, I'm going to post the code on the blog so you can see it, but I'm not actually going to go through how to solve it in detail. But if you have questions about this way of solving it, you can ask me on the blog, you can look at the code there, and hopefully you'll be able to understand how you could do it that way, which would be a good solution, but we can do even better. And so we're going to look at how we can do even better. So the way that we can do even better is by modifying our original list. And so let's think about this for a second. So what we really need to do is we need to know how to get to, we basically need to match our nodes in our new list to nodes in the old list, right? So that we can actually, when we get the next node for a node in the old list, we can get the equivalent next node in the new list, or the equivalent random node from the random node in the old list. And how can we do this? There are a couple things we could do, but one way that we can do this is by the first way was creating the mapping that we did. But a way that we can do this without actually using any additional space is going to be by modifying our original list. And this is not necessarily something that I would, if I were interviewing you, I wouldn't expect you to come up with this on your own, but if you know this, it's a cool algorithm. So we're going to go through this. So you can actually insert your new nodes interleaved with the nodes in the original list. So let's look at how this would work. We're going to add a node, so we're going to duplicate our list. We're going to put a 1 here, a 2 here, a 3 here, and another 4 here. So we're going to do 4. And then we have to space these out because this is what it's going to look like. All the nodes that we just created are going to have random pointers as well, but they're going to point to null because we haven't actually initialized them. So obviously, again, it's like duplicating the linked list. This is going to be very easy to do because we're just going to iterate through the list, and between each we're going to just insert a node, and that should be pretty easy to do. And we'll go over how to do that, but it's going to be fairly straightforward. And these just have null pointers in their random pointer slot. So now let's think about how would we get the next node. So we're going to traverse this list, and we know that we can basically go look at each even node is going to be in the old list, and each odd node is going to be in the new list. So, or actually, sorry, the other way around. Each odd node is from the original list, so the first node to third node, et cetera, is going to be in the old list, and then each other node is going to be in the new list. So let's look at this node first. We look at the original node, and we see that it points to the node 3, which is this. And then we're trying to set the next node in for this node, the equivalent node in our new list, and we know that each node in the old list is immediately followed by the node in the new list. So I can say the random node for 3, or the random node for 1 is 3, so I go here, and then the next node is the equivalent node for our new list. So I can just say the random node, which is this one, dot next, is the node in our new list that goes here. So it's really easy for me to just generate that, or to just get that. And it'll hopefully become more clear as well when we look at the code, and it's notationally, I think it's going to be very, very simple, because we're doing basically node.random, which is this one, dot next. So node.random.next equals node.next.random. So it's going to be very simple, but it works well. And then the final thing so we can do this for the whole list. And then all we have to do afterwards is we have to separate this out. So we're going to have to come up with a way to actually split out the original nodes so that we can we're going to have to separate them into 2 lists, but that's also not going to be very difficult. And we'll see how to do that when we actually write the algorithm. All we have to do is basically grab out every other node, and all we have to do is link each node to the node 2 ahead of it, right? So I say link this node to this node to this node, this node to this node, and this node to null, and then this node to this node, this node to this node, and this node to this node. And then by doing that, just by changing the way they're linked together, we're going to end up with our original list and also our new list. So let's get into how we're actually going to solve this, and hopefully this will make it a little more clear how this algorithm is going to work. But we are going to create a private node class that's going to have our node, and I'm not actually going to have any value in this, but you could certainly add an int value element or variable into each node. I'm just not going to worry about it because it's not important for the purpose of this problem, I don't think. So I'm just going to do node next and node random. So this is our node class. It's super simple. And then we're going to do public node clone. And so what this is, it's going to return a node, which is going to be a pointer to our cloned list. And it's going to take in a node n, which is going to be our original list. So let's think about how we're going to do this. First, we want to, obviously, we're going to do this in 3 steps. So first what we're going to do is we're going to insert these nodes interleaved with our original list. Then once we do that, that's going to be our first pass. Then our second pass, we're going to go through and we're going to set all the random nodes, as we talked about. And then we're going to do a third pass, which is going to split them up, and then we're going to return our original node. So let's start with the first thing is I'm just going to do a null check. So if n equals null, then we can just return n, because that sort of doesn't really make sense, or we're not going to want to deal with that case. So it's easier just to return it. And then if not, let's think about how we're going to do this. So we want to insert a node between every node. So I'm going to create a pointer that's going to point to where I'm at the list in a given time. I want to keep n and not change the value of n, because I want to have a pointer to the beginning of my linked list. So I'm going to say ncur equals n, and this is going to be my pointer that I'm going to use to iterate through the list. And then we're going to actually iterate through the list. So while ncur is not equal to null, so while ncur is not equal to null, I'm basically going to insert a node in front of ncur, and then I'm going to increment by 2. So if you think about it, I would have 1, 2, 3. I'm going to say ncur equals 1. So ncur.next equals new node, which let's call it 4. and then ncur is still 1. So I'm going to skip, I want to skip this new node that I just added and go to the next node in the original list. So I'm going to do ncur equals n.next.next, and then I'm going to insert another node here. So I'm going to say .2.next equals new node, which can be 5, and then this was ncur, so I skip 2, and then I do it one more time, so I like 6, and then I skip 1. This is where I was. I skip 1, 2, and then I have null here, and so it's null, and so I break out. So all that's going to look like is I have to actually save the original node, so that I have to save the next node so that I can get there, right? So I'm going to say node temp equals new node, and then temp.next equals ncur.next, ncur.next equals temp, and ncur equals ncur.next.next. So hopefully that makes sense. All we did was copy, so we created a new node, we set the new node's next pointer to point to the current next pointer, and then we set the current next pointer to point to the new node, and then we increment by 2. So that's our first part. We just interleaved our nodes. And so now the next thing we need to do is we need to go through and set our random pointers. And as I said before, this is actually going to be quite straightforward because of the way that we have it's basically going to be ncur.next.random is going to be equal to ncur.random.next. So as we will see, ncur equals n. We have to go back. We're going to loop through again. So ncur equals n again. And again. And then while ncur is not equal to null, we're going to say that, okay, so ncur.next.random. So let's say we're starting at the beginning here. ncur.next.random is going to be the value that we're trying to set, because we're going to increment ncur by 2 each time. So ncur is always going to point to one of the nodes from our original list. So we're going to do ncur is this one, then increment by 2 is this one, then increment by 2 is this one, and so on. And then once it's null, we stop. And then we're going to say ncur.next.random is going to be equal to ncur.random, which is this, .next, right? Because that's going to be .random.next, because that's going to be the equivalent node in our new list to the node that is in our original list. So hopefully that makes sense. And then all we have to do is say ncur equals ncur.next.next. And I will point out briefly, you'll notice that I'm doing this .next.next without actually checking that that's non-null, or that .next is non-null. And the reason I'm doing that is because since we interleaved them, we know that there's going to be an even number of nodes. And so I know that I can always skip ahead 2 and not run into problems. But that is something that you might mention to your interviewer, because normally you would want to check that. But in this case, we've sort of set it up so that that can't possibly happen. So now the last thing that we want to do is actually split up our list. And what I'm going to do for this is I'm going to set a node I'm going to have ncur, and I'm going to iterate through the list. And I'm going to start by setting this point. I'm going to create a new variable that's going to be this pointer, because it's like the first pointer in our copy list. But then I'm going to have one runner. I'm going to have ncur. I'm going to iterate through, and while ncur.next is not equal to null, I'm going to say ncur.next equals ncur.next.next. So what you can imagine is going to happen. So let's just look at this example again of just a very simple example. I'm going to say that, so our n equals 1 still, because n has always been equal to 1, and then c, or copy, is going to be equal to 2. Then I'm going to say ncur equals 1, so I'm going to say ncur.next is going to be equal to ncur.next.next. So I'm going to say ncur.next equals 3. So we're going to end up with n now equals this, and copy still really equals this. And then I'm going to increment ncur by 1, so I'm going to come here and I'm going to say ncur.next, which is currently 3, equals ncur.next.next. So I'm going to say this dot next equals 4. So I'm just going to remove this pointer to 3 and make it point directly to 4. And then I'm going to come to 3 and I'm going to say ncur.next is not equal to null. So I'm going to point this to ncur.next.next, which is null. And then this is going to be ncur.next equals null. And so this is already pointing to null. And so that's going to be how we're going to separate them. Hopefully that makes sense. It's going to be pretty clean and simple code. We're just going to have a node copy equals n.next. And again, we know that n.next is non-null by definition because we already checked if n was null at the beginning, and as long as there's at least one node, then in the original list, then we have at least 2 nodes in our current list. So we don't have to worry about that. And then I'm going to say just ncur equals n. And now I'm going to iterate through. So I'm going to say while ncur.next is not equal to null, I'm going to say that ncur.next equals ncur.next.next. And I'm just going to loop through that until the end, and that's actually all there is to this. So the only thing we have to do now is to return copy. So as you can see, I just really broke this into 3 discrete parts. I have the part where I interleave the nodes, I have the part where I copy the random pointers, and then I have the part where I separate them again. So hopefully this all makes sense. It's a little bit of a tricky problem, but let's go through briefly a very short example. So I'm going to get rid of this longer example, and we'll do something that hopefully will be fairly short. We'll just do 1, 2, 3. And then we'll do, these are going to point to, doesn't actually really matter, but we'll say 2, 2, and 1. So we're going to first interleave them. So let's see, ncur equals 1, and while ncur is not equal to null, node temp equals new node, and temp.next, so we're going to have insert a node in here. So this is temp, or imagine the value is equal to 1 here. We're going to insert that. Temp.next equals 2. 1.next equals 1. And ncur equals ncur.next.next. So let's say this was ncur originally, and now we're going to say .next, .next. And then we're going to insert another temporary node here. So we're going to put 2. And then increment this, and then finally one more, we insert a new node 3. This comes over here, and now ncur is equal to null. So we've now interleaved the list, and so our next step, ncur equals 1 again. So we're going to come back to the beginning, and we're going to say while ncur is not equal to null, ncur.next.random, which is this here, equals ncur.random.next. So equals this 2. Then again, we're going to increment this by 2, so ncur.next.next, and ncur.next.random equals ncur.random, which is this, .next. So again, it equals itself, which is what we expect. And finally, we increment this one more time, and we say ncur.next.random equals ncur.random.next, which is 1. Now, finally, we have to separate them out again. So we're going to go back to the beginning one more time, and we're going to say that copy equals 1, and this is going to be a little hard for me to represent in the text editor, but this would be something where you can draw pictures on the board, and that would be great, and that would do a good job of explaining sort of what it is that you're trying to do. But you're going to say that you're basically going to take this pointer and point it to here, this pointer and point it to here, this pointer, point it to here. You're basically separating them out. So this is going to become, we're going to end up with two linked lists that look the same. I'm not going to try and represent it in a way on here because it's not going to be obvious what I'm doing, but hopefully that makes sense. Our code looks good, but it would be good for you to draw this out on your own and make sure that it works. And lastly, as we talked about a little bit earlier with the space complexity, I mean, the time complexity is just going to be big O of n because we are just looping through, we're going through the list a constant number of times. So it would take basically 3n time or O of n time. And then space complexity, we obviously are going to we're going to take up linear space because of the resultant list that we're creating, but other than that, we're not creating any additional map or anything. So the space in addition to the result is going to be constant space. And so this is a little bit of a better solution than the other one. Not a significant improvement, but I think it's a cool solution. So hopefully that made sense. Hopefully you guys enjoyed that. I will have another question for you guys next week, so I look forward to seeing you then. As always, if you have comments or questions, leave them on the video or on the blog, and I will see you guys again next week.